Well, that was a great show, and I was especially interested in all of that capacitor stuff, which was just great, Jerry.
Well, thank you, Ken.
And I'm going to continue on sort of on the same lines because I started looking into some things that have to do with electrostatics and capacitance. And especially what I was interested in was figuring out a way to explain to people what exactly is voltage. I mean, you know, we hear about it, and I remember when I was a kid and I first heard about it, and I knew that a battery had voltage and that you could stack batteries up and you could get more voltage. But the question which I had when I was reading the books and things when I was very small is, well, what is it really? You know, what thing is it? And it turns out that voltage isn't anything, and that's why it's, you know, it's a little bit confusing. And eventually, I heard that, well, they would say it's potential. So it's, well, what does that mean? And go look up potential, and that wasn't clear either, until I sort of figured it out eventually that what it means, what voltage really means, is the potential for something to happen. And that something to happen is for current to flow. And it's the potential, sort of like if you were up on a cliff, the potential for you to fall down that cliff, which wouldn't happen if you were at the bottom of the cliff already. You wouldn't have the potential to fall down the cliff because you would have already done so. And that is really what all of this electricity is about. It's about separating electric charges so that they're apart. And if they're apart, then they have the potential to get back together again. And that potential is, you know, what we call voltage. So I started making an apparatus which demonstrates the principle that is actually behind both the Wimshurst and also the Van de Graaff generator. And it uses the principle of expanding a capacitor. So I took one of our friends that we always have sitting around, which is an extra CD that maybe came from AOL or some other, you know, useless type of thing, and I glued aluminum foil onto one side of it, the side that doesn't have the little ring that's in here but is flat, and then on the other side I glued a plastic handle so that I would be able to pick this up and move it around. And then the aluminum foil has a little tab that comes over onto the other side so that I can make electrical contact to it when I want to. And then I took a box that's just a metal box and put aluminum foil top on the metal box, and I have taped onto the top of this a clear sheet of Mylar, and that's my insulator. So this makes a capacitor. Here we go. Our just exactly what we were talking about, where this is one plate of the capacitor, the top of the box is another plate of the capacitor, and the Mylar in between is the dielectric. Now, Mylar, which is also polyester, is a really good dielectric, and that would, by the way, be a good belt for your Van de Graaff. So we'll maybe talk about that later. But the important thing about this particular apparatus is that this will demonstrate the ability to make voltage. And what it does is it makes voltage when you set up a small amount of charge difference across this plate, which you can do by rubbing things on it and other type of static electricity things, so that there are charge carriers on one plate and different charge carriers on the other plate. And then you pull it up like this. So it is the pulling up, the separating of charge carriers, where force is applied over a distance in a field that will then create a big voltage difference between here and here. So another thing I did to make this, to demonstrate this, is I built my own capacitor, which is right here. And this capacitor is made by rolling up a couple of pieces of aluminum foil with plastic in between them, so that I would end up with the two different plates on the two ends. So I have bare metal on each of these two ends. And I can connect it to ground underneath this, this box and set it up so that I can pull up, let me get this in camera here, it's kind of off the edge, so I can pull this up, generate voltage, dump it into the capacitor, then put this back down again. I'm going to use a little clip lead here. Then come along with a clip lead, send part of the charge back into the plate, and then multiply it so that I get even more voltage from where I was before, and then dump that in there. Then put it back down again, because the voltage goes down when it drop it back into the field. Then come along, put some back in, and multiply that up. So this is what happens in the Wimshurst machine, only it does it by having plates that go past each other this way. So they have a small charge when they're just facing each other at a small distance, and then the rotation of the two wheels pulls the plates apart, and that is what boosts up the voltage. And then some of that high voltage charge is circulated back again to plates where they're close together, and then more of it is pulled apart. So what I need to really show this, and to really show this happening, is Monty's non-contact voltmeter, so that I could actually show the field. I can't, at this point, until I go get one, show you exactly how much this increases when I pull the plate up. But that is how you make voltage. You make voltage by having charge and separating it in a field over distance. Okay, so that's what I've got on this end. It's a project that's still going, and if you've got any questions, then fire away.
I love that. I love how mechanical, by hand, you're dumping charge. It's like a bucket brigade of moving electrons over.
That is exactly what it is, and if it's done properly, you are charging up this capacitor a little bit each time. And while I'm at it, on this capacitor, I'll show you this thing, a little rubber band holding it together. This is rolled up, but if I unrolled it, how this is made is simply by having a little plastic bag and putting one of the pieces of aluminum foil inside of a flap made out of this plastic bag, such that it almost covers the foil, but not quite. You have to have some sticking out on the edge. And then you just take another piece of aluminum foil, which is right here, overlap it, and roll it up. And by doing this, this was a 0.02 microfarad capacitor, and it's capable of a lot of volts, and you can just make your homemade capacitors that way for doing high voltage stuff. So again, back to your capacitor part, it was great.